Imagine the sun just blinks out. You'd expect instant darkness, right? But the true first moments would be deceptively normal. It's after those first critical 8 minutes that a cosmic ripple effect would begin, rewriting the fate of Earth and every planet in our solar system. When the sun vanishes, we wouldn't notice immediately. Light, despite its incredible speed, takes time to travel. From our star's surface, photons embark on an 8-minute and 20-second journey to reach Earth. So for just over 8 minutes, Earth would continue to be bathed in sunlight, entirely oblivious to the monumental event. This initial grace period would be profoundly unsettling for anyone expecting instant darkness, but light isn't the only information traveling through space at a finite speed. Gravity does too. Albert Einstein showed us that gravity isn't an instantaneous force, but rather a distortion in spacetime that propagates at the speed of light. If the sun were to disappear, its gravitational influence wouldn't vanish across the solar system all at once. Instead, a gravitational ripple would spread outward, taking the same 8 minutes and 20 seconds to reach Earth. So after those initial moments of deceptive calm, the true cosmic shift begins. At precisely 8 minutes and 20 seconds post-disappearance, two fundamental changes would hit Earth simultaneously. First, all light from the sun would cease. The sky would plunge into an inky absolute blackness even at noon. The moon, which only shines by reflected sunlight, would vanish. Stars, once obscured by the scattered light of our sun, would suddenly appear with stunning clarity, a celestial dome of countless points. Second, the sun's gravitational tether would snap. Earth, no longer bound, wouldn't fly off into deep space in a straight line, but rather begin a new journey along a tangent to its former orbit. It would continue moving at its orbital speed, roughly 30 kilometers per second, simply drifting away from where the sun used to be. For the other planets, this same sequence of darkness and gravitational release would unfold, each at their own staggered travel time for light and gravity. Mercury and Venus would feel it sooner, while Jupiter would remain gravitationally bound for another 32 minutes after Earth's liberation. Neptune wouldn't even know the sun was gone for over 4 hours. On Earth, temperatures would plummet. The lack of incoming solar radiation would quickly cool the planet's surface. While Earth's vast oceans and atmosphere would retain some heat, acting like massive thermal batteries, the drop would be precipitous. Within 24 hours, surface temperatures, particularly on what was the day side, would fall dramatically, likely well below freezing. Photosynthesis, the foundation of most life on Earth, would immediately cease. Plants wouldn't instantly wither, but the energy production that sustains them, and indirectly us, would halt. Humanity would be plunged into a struggle for artificial light and warmth, facing a sudden and profound shift in our fundamental relationship with the cosmos. The disappearance of our star, even for just 24 hours, would reveal the intricate dance of light and gravity that governs our solar system, an elegant yet ultimately fragile balance. What hidden connections in our universe might we take for granted until they too ripple away?